welcome to the tutorial for R squared for simple linear regression. Okay, we're going to be using the coffee.csv data set. We've used it before. It's linked in the description below. We've also, if you've looked at any of the other videos, you'll know how to read it in because we're going to be working with it. Okay, so this concerns the coffee per week that you intake and your 11 a.m. anxiety level. So here's a scatter plot of the data, and what we want to know is how well does a line fit this data? Okay, so if we don't use X, okay, and we ignore the value of X at all, then our best guess at anxiety is just the average of it, right? I mean, so if we don't know these X values here, then all of this data would be stacked over here, and our best guess at what the value should be is the average. So we want to see how well does the line do versus just ignoring X and just using the average. So first thing we need to do is get this idea of variation, because this is what we're going to be looking at, is the variation in the data. So this particular here are these lines that are coming down are measuring the distance from the average to the point. Okay, so that's what these are indicating. So we want to add up all of these bars, or the size of those bars. We don't want to just add them up. We're going to actually square them, but we'll worry about that in a minute. So this is the overall variation because it goes from the average to the data. But we could see how much variation is explained by the line. So we could look at instead of looking at the observations directly, we could look at what our guess at what the observation would be, which is the line. So we're going to take the distance from the average to the line for each of these data points, and that's what we're going to call the explained variation. This is how much variation that we can explain using a line. And then there's what we miss, okay, what the line doesn't pick up, and this is what's called unexplained variation. And you notice here this doesn't involve the line at all, okay, so keep that in mind. We're interested in specifically how well the line works. So we're going to be interested in these two pieces, the overall variation, which I have over here, and the explained variation here. And here are the formulas for them. There's what's called the sum of squares regression. This is the formula for the explained variation. Notice it's the line, that's what y hat stands for. It's the line and the minus the mean. So this is the distance from the line to the mean. The other one we're interested in is the observation to the mean. Okay, if we come back up here and look, we can see the observation to the mean. This is the line to the mean. So you can see those are two different distances. And the sum of squares error is these little bits that are left over. These are unexplained. We don't know why they occur. They're random. So we're going to call them unexplained error. So we have sum of squares total, sum of squares regression, sum of squares error. Okay, and again, I mentioned that SSE does not reference the overall mean. There's no lines going from the point to this pink line across here. So this also works for multiple linear regression. It just doesn't work well in pictures. Okay, so how are we going to do this? What we're going to do is we're just going to create this ratio here, and we're going to call it R squared. It's going to be the sum of squares regression over the sum of squares total. So how much variation we explain over the total variation, and that makes it easy to interpret. Okay, first, since it's R squared, if you noticed in the formulas, everything had a square on it, and this S in the middle means squared. The fact that it's squared means everything has to be positive. We're adding up a whole bunch of positive numbers, so there's no way it can be lower than 0. The other thing is since this is a total variation, and this is going to be less than that, it's going to be less than or equal to 1. If we get an R squared equal to 1 or near 1, what it means a lot of the variation in Y can be explained by X. If R squared is near 0, that means X doesn't do a very good job of telling us anything about the value of Y or why the reason that Y varies. Okay, a little side note here. R squared is also R squared, where R is the Pearson correlation coefficient. Okay, so let's give this a go. So we're going to have the important takeaway here is the interpretation of R squared. R squared is the proportion of the variation in Y that is explained by X. So it's a proportion of variation. So we can say how much of the variation, the reason that Y is not the same value, why it varies, can be explained by the value of X. Okay, so I have the coffee data set uploaded here, and I'm ready to work with it. I'm not going to worry about the fact that coffee is numeric, but it's got it listed with these little categories. It's not going to really affect what we're doing. So what we're trying to do right now is get the R squared, and we're going to go to Analyze. And once we've hit Analyze, we're going to go down to Regression. We're going to go down to Linear. And our dependent variable is anxiety. Our independent variable is coffee, and that's all I'm going to do is just these two together. And then I'm going to run this, and in my output you will see model summary here, and we're going to jump back over to the slides so that you can actually see this blown up, and we'll talk about it more there. So now that we've done this in SPSS, here's the output, and you can see right here that we get an R squared of 0.931. We also get R, and if you take this number and square it, you'll get R squared. There's this thing adjusted R squared. We'll worry about that later, but you can see here, in here, it tells you what the predictors are. So we have coffee is in the model. That's it. That's our only predictor, and our dependent variable is anxiety. And so, using the number of cups of coffee per week, we can explain 93.1% of the variation in 11 a.m. anxiety levels. And that's the whole point of using R squared, is to understand how well your model fits, or how well X does at predicting Y in the data set. Now, it doesn't say how well it does outside of the data set, but how well the line does at explaining the variation. All right, so the next thing we're going to look at is, what if we want to do larger hypothesis tests, and they're going to need these same ideas again. So I will see you there.